Well, we said we wanted a number that would measure the strength and direction of a linear relationship, and that's what we're going to discuss. The properties of the linear correlation coefficient, also known as R for us. Now we use a lowercase r. Sometimes computers will use capital R. Don't worry about it. It's R, the correlation coefficient. Now the sample correlation coefficient is the sum of, when you look at it, it's the z-score formula, right? So it's a z-score for the x times a z-score for the y, and then you sum them all up and divide by n minus 1, which is your degrees of freedom again. Now, don't worry about the formula because we will never find this by hand. Never, never, never. We're going to use technology instead. So by technology, I mean you can use either a TID4 or a StatCrunch, right? Now, R is not resistant to outliers, so it gets affected by extremely large or extremely small unusual data values. It has no units, right? So it's unitless. It's an important thing to note. Right? We're never going to find it by hand, ever, ever, never, never. And it's unitless. And we usually round to 3 to 4 decimal places. Now, R does not tell you if the relationship is linear. For that, you have to know a little bit more. You have to kind of look at the graph, look at the R value, and then do some calculations, which we are not going to cover. That would be chapter 14. If you already know the relationship is linear, R can tell you how strong that relationship is, and also its direction. So R gives you strength and direction. Direction is positive or negative only, and strength is the strong, moderate, weak, that kind of thing, right? So I'll just put perfect, strong, and I'll just put a ellipsis, dot, 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 right? Okay, so let's think about the properties of R for just a minute. So I just said it tells you whether it's positive or negative by its sign. So the sign will tell you positive or negative. So if it's positive, that means there's a positive relationship, a direct relationship. And if it's negative, that means there's an inverse relationship. So this one would mean going up. This one would mean going down, right? And then the absolute value of R describes the strength. The closer R is to 1 or negative 1, the stronger that relationship is. So strong relationships are actually close to 1 or negative 1. Negative 1 would just be a strong negative. Positive 1, well, positive 1 would be a perfect positive. Weak relationships are actually close to 0. And I have all this written out on a lovely number line for you, which I've actually also put onto the exam notes packet. And I've color coded it. So perfect is actually only the numbers -1, that's a perfect negative, and +1, that's a perfect positive. And that's it. Strong positive is here from 0.8 to 1, right? But not including 1 because 1 is perfect. So right there, strong positive from 0.8, which is less than or equal to R, which is less than and then 1. So from 0.8 up to 1, but not including 1. And then same thing over here from -0.8 to -1, but not including negative. So if I was going to color code these are green. So this is the green zone right here, from the strong negative and the strong positive. Those are the strong zones. The moderate zones are in blue. They're from 0.5 to 0.8. So you have -0.8 to -0.5, +0.5 to +0.8. Right? And that dot there is blue, that dot there is green. Right? Although, to be fair, we don't really get the exact values. The way these work, they have lots of decimal places. So you're not going to have, 0.5. You're going to have 0.523, things like that. So you'll have to know, where does it fit on the number line. And of course, keep in mind, this is the number line. So that's 0 in the middle. Technically, these things go on, but you can't go past their values of -1 and 1 for an R value. So I don't bother showing you any more of that number line. The weak relationships I have in orange. There's weak negative and weak positive. Weak negatives over here, weak positives over here. And then there's the no relation at all, which is in the middle. Right there. That kind of pink zone right there. Okay. I realize that my 0 is a little wobbly. It's meant to be straight. Okay, and that graph is reproduced for you on your exam notes packet, so you don't have to memorize it, you just have to be able to use it. Speaking of using it, let's use it over here on this example. So we want to gauge which of these graphs goes with which correlation coefficient number. Okay, so let's see here. 1 and -1 should be the easiest to place because 1 would be a perfect positive and -1 would be a perfect negative. All right, so if I look down at the graphs below, I can see that r is equal to 1 right here because that is a perfect positive relationship. The ducks are all in a row, right? The dots are all in a row. And down here, this is r equals -1 because that is a perfect negative relationship. And again, we don't work with perfect relationships very often. Matter of fact, hardly at all. It's just a looking at it kind of piece. Those are the kind of relationships we see in algebra class, but not so often in stats class. All right, so these two I've done. So I've done r equals 1, r equals -1. They're finished. So now I see -0.95. That's the strongest relationship out there that is not perfect. So when you look at the graphs, what you want to do is look at the way that the dots clump around the line. Strong relationships will have the dots really close to the line, and weak relationships, like the ones down here, will be far away from the line, which lets you know that these two are the strongest ones. This one must be r equals -0.95. This is a strong negative relationship. It's actually very strong. Over here, I have r equals 0.83. Those dots are pretty close to that line. It's pretty nicely packed. And it is a strong relationship. It's just not as strong as this one was. Strong positive. Right? Positive because it's going up, negative because it's going down. The strength is measured by how close those dots follow that line. Right? Perfect, of course, is when they're right on the line, but we can't always have nice things. All right, so 0.83 is done. Now let's see here. Well, 0.11, I'm actually going to go for that one because that should be the worst one out here. Do you see how it's the lowest number of all of the numbers? So that's going to be the worst graph. So if I scroll down, it's this one. If you took that line out, take the line away for a second. It's a blob, right? It's a blob of points with a slightly positive slope, right? So this has got to be r equals 0.11, which if you remember from the list, let me bring it back. 0.11 is in here. It's so weak, let me put it that way, it's no relation at all. No linear relation. And you can see it when you look at the graph. If you took away that line, you'd have no relationship. All right, so 0.11 is done. Matter of fact, while I'm on the subject, let's do -0.22. So it should be a negative line. So it's got to be one of these two. And it's definitely going to be the second one. Right? If you took that line away, you actually wouldn't necessarily even know that that's negative, right? So this is also no relationship. -0.22 is no relation. Well, how did I know this was 0.22 and this was the 0.11? Well, 0.11 is positive, and you can see the computer's drawing a positive slope line. So this one has to be the 0.11, and it actually is a little bit weaker, I'm sorry to say, than this one. They both are no relation. This is even less of a relation than that one is. This one, if you took away the line, you'd still know that there was a relationship. Well, you'd know that there was a shape. It looks a little bit like the flag, right? The American flag, there's like stars here, right? But it's terrible. There's no relationship. It's so weak that it's gone past the weak zone into the no relationship zone. Right. All right, that leaves us with just 0.59 and -0.44. Okay, well, this one's got to be 0.59 because it's got a positive slope. Again, that computer figures that out. So if the computer knows it's positive slope, then it has to be a positive r. So 0.59, let's measure that. Here's 0.3, here's, so 0.4 is in the middle, 0.5, 0.59 would be over here. So it's in the moderate positive zone. So this is moderate, positive. This one is r equals -0.44. So let's read this. The negative ones are always a little harder. Negative 0.3 is here, so negative 0.4 is right there. So negative 0.44 is in this little orange zone, so it's a weak negative relationship. A lot of the guesswork is removed for us because, of course, having those correlation coefficient numbers and having the lines drawn by the computer means that we're able to attach without really thinking about it. Like, this is the strongest one. This is the next strongest. The perfect ones are, of course, the really, I should say that. The perfect ones are the strongest. But we kind of knock those out mentally because, of course, they're perfect and we don't really work with perfect, right? Perfect is algebra class, not stats class. So the next strongest one is this one, right? And then followed by that one. And then the weakest one is actually this one down here. That's the weakest, that's the second weakest. They're both terrible, right? Awful, right? They're not really relations.